you think for certain types of apps that have configuration associated with them, that's going to be the sweet spot for containers. For a single binary that doesn't require a lot of configuration, that's where RPM works. That's right.
All right. Anything that we haven't covered here already inside what a conversation? We're going to talk about the networking, Kubernetes. We're going to cover Kubernetes with that. Okay. I'm going to do Kubernetes because there's the majority of it.
So yeah, Kubernetes is, so let's talk about what it is, what it does first. So Kubernetes was a mechanism for orchestrating containers that was based on some of the research work that Google did. Now, I said earlier that Google deploys 2.x billion of containers per year. That is a true statistic. They did release Kubernetes. Kubernetes is not the tool that they use. It's taking all the best practices and all the things that they learned about orchestrating containers and putting it into an open source project. So Kubernetes was open source in a collaboration between Red Hat and IBM. It was designed around creating this declarative framework so that way, if you wanted these multiple hosts running, Docker format or some other container mechanism, if you want to deploy your app in a way that you could describe it within a text format, some sort of template, and then have a system be able to deploy it out amongst multiple hosts, that's the problem that Kubernetes solves around container orchestration. Kubernetes will also do things around like network configuration management, also things around network namespace management. So that way, if you need apps that either depend on each other or containers that depend on each other. So if you have let's say like a web, like an HTTP app or container that may need to depend on your app or a SQL container, you can define those relationships within the spec. So it's very powerful. Kubernetes uses a terminology called a kubelet. Excuse me. That's what's called it's worker node here. It's actually a minion within the framework. So we have a demo of it towards the end that we can show. So when you actually tell Kubernetes to do something, you're feeding into the master, hey, I want you to deploy this pod. A pod can be either one or multiple containers. Within, I mentioned Project Kala earlier. And Project Kala was sort of designed around deploying OpenStack, so we use some OpenStack things. When you break down an app, let's say Nova is an app within OpenStack. Nova can be broken down within 5 different types of sub-applications. So you have the API server, you have the Nova C proxy, you have the conductor, you have the scheduler. You have all those different sub-apps. And so you can break Nova down into 5 different containers, all running this single daemon each. And all those 5 get deployed simultaneously as a pod. And that is the Nova app. And you can deploy multiple apps on multiple machines. And the idea is that these pods may or may not have a relationship to each other. And so as we'll see later, you can define that relationship, or they can be completely different apps that are fed in by completely different vendors. So we already talked a little about microservices. There is definitely some work that Kubernetes is doing to expose more of the Docker runtime features. So some of the things that you could expect from Kubernetes is that it will deploy your app as a pod, and then you also have to create what's called a service definition that will actually expose ports that are usable from outside the cluster. So if you deploy your HTTP app, you have to deploy your Apache container, but then you also have to deploy a service that then describes that Apache app to make it reachable on port 80. So there are things that Kubernetes does that expose some of the features. It's not going to expose them all. It's going to expose the most useful things.
All right, so let's take a breath and be completely confused. All right, we're still kind of on track.
No, but we have one question. I understand the deployment along the left, but there's something that one thing,
yeah.
And that kind of
No, not different kernels.
Different user space.
Different user space.
Okay.
You still run the same kernel, but the thing is, so the user space, you can basically package up the user space and put an application as a dependency onto your own and then deploy that onto a well-7 host that's on
if you entered every container on the host and ran uname times a, you would get the exact same result from every single container on that.
Even the relative runs on the left side.
That's right.
You'll see the relative kernel and the relative container.
So it has to be something that kernel then can't have some kind of compatibility with your application. Kind of have to test it out.
Yeah, that's right. That's right. I mean, most applications don't interact with the kernel directly. Most applications are going to interact with the syscall interface that glibc is going to provide.
Yeah, sometimes there can be a bug.
Absolutely right. Absolutely.
So
If you install a very specific device driver and your application depends on that device driver, you have challenges to overcome.
Absolutely.
Now, part of the story of Docker and containers and Red Hat strategy, and the next topic will be the super privileged container. I don't like that term because it makes it sound like you're giving a container a privilege of some sort. I like it more of a paroled container. Because the purpose of the container is I'm jailing it to isolate it, to virtualize the app so it can't see outside the space. But the super privileged containers can now take some of those namespaces and expose them like a gate so that the application can actually get to the host underlying namespace. So, but that's my term on video. That's not our
Parole.
So sorry, the Kubernetes is a language?
It's an orchestration utility that has you feed it YAML that then describes your application in terms of here are the containers, here are the ports it's using, and then it orchestrates the deployment of your application. That's
Kubernetes is an application feed it text, setting stuff like that. Docker's also an application
that then
Kubernetes
runs,
talks.
it actually executes the container.
and Kubernetes talks to Docker.
That's right.
Yes,
That's right.
The objective is to get
Similar.
people away from using Docker commands, just like when we deployed KVM or Zen in RHEL 5, right? We created libvirt, the project libvirt, so that people wouldn't be using the Zen command, right? We wanted them using an abstracted, portable, open source API for managing VMs. Same kind of concept, even though Docker is really cool and strong and powerful, you kind of want to keep that dependency away. So Kubernetes right now is the means to keep you out of the weeds.
And if you replace Docker with something more principled, Kubernetes will then have the same functionality.
Absolutely. You're interfacing with the Kubernetes API, and so it's a layer of
But that's
abstraction.
sort of what you expect. I mean, we're supposed to learn one thing for the best practices.
Kubernetes.
Say, learn Kubernetes and let everybody else work out the Kubernetes, Docker, Kubernetes, whatever.
Absolutely, yeah. So that's why, like, when you interface with CoreOS, you would interface with Kubernetes, not necessarily that.
So, for all of you with your laptops, playing with Docker is straightforward and simple. You go find the README that install the bits that you need. You start downloading these from the registry. You start downloading your images. And you say run. Those images aren't always built with the intent of being something deployable in a Kubernetes pod. It could be hobbyist guy just wants to put Mongo or some other application in the container. So there's lots of things, and that brings up this topic, right?
And it also kind of keeps your host system a little cleaner.
It absolutely keeps it cleaner.
Literally.
So a good example is here, right? If you wanted to pull MongoDB from Docker, right, using the Docker registry, that's calling. Let's say you want to pull that container down. You want to run Mongo. You just type in the Docker run command with that container Mongo, and it's going to go off and run Mongo for you. But then once you want to destroy it, you run Docker kill, give it the UID of the container, and it's going to get rid of it. And all of a sudden, there's no more process running. If you want to remove Mongo from your system entirely, you would remove the image Docker RMI. And that's a good way. So it does, to your point, it does keep the host system very clean. It really confines that user space into its own separate area.
And I do a lot of GPU programming, and that makes it happen as well. And there's a case where there's particularly private versions or whatever.
So, I mean, from some perspectives, right, the Docker format, like you said, becomes a very interesting packaging model. Because now I can bundle everything up into a deployable container, but you might still have dependencies. So aside from all the namespacing and making you probably just like the packaging model, you can use the super privileged, set expands to basically remove all the jails and then deploy your container and get access to all those parts of it. So that might be suitable. All right, we're talking about security and, trusting the sources. If you go to the Docker registry and you go search for Mongo, you'll find that, there's hundreds of actual packages you can pull down. So now it's like, well, who built it? What does the actual runtime include? Is there some kind of a hidden Trojan that's going to expose my company to something? Um, and that's, where Red Hat's been building its bread and butter for a couple of decades now. We signed our RPMs, we've got QA and deployment tools so that you as a company or a customer can consume our products and feel confident that the package you deploy came from Red Hat. It's gone through the QA process, been certified, etc. So we're now applying that same principle to the container world where, when you register a system with Red Hat, we have our own registry to deliver the Red Hat OS pieces. You can then also connect it to the Docker registry and benefit from those as well. But over time, we're going to build up our library of tools and things that we'll be shipping from our registry.
The two middle points on the certified containers are probably stuff that we've been talking about. Because, to a point that was made earlier, when you talk about the enterprise portability, that's where we're guaranteeing that this container will run. So that's what we mean by that. The second thing is that the enterprise lifecycle. One of the big sticking points for container adoption within enterprise now is if there is a security problem within the container, let's say there's a new poodle or something else, another shell shock exploit that comes out, who's on the hook to patch that? And having that trust model of knowing that there is somebody on the hook to patch it, maybe it's Red Hat or it's a trusted container that we have an agreement between Red Hat and the ISV that it's supported, it works, and we're going to work with the ISV to patch it when there is a security flaw. Having that confidence that you can deploy it knowing that there is an enterprise lifecycle behind it, it just means that if you do get into a model for deploying containers in your enterprise, you're not going to get stuck and say, oh, I've got 2,000 instances of Tomcat, but all of a sudden it's exposed to this new shell shock bug because I didn't think about what were the implications of people using containers and container boxes. So it's a big problem that's on the horizon.
And another thing that's been challenging for enterprise companies is that, you upgrade an operating system, oftentimes I need to roll that upgrade back out because I had a specific problem. Since we've been talking about Docker and this whole image, it's in the container world, you're deploying an image. And with Docker, that format allows for layering of images so that when you build your application, you can include a small chunk of your app, and then say the dependency for this app is a rel6 image. And so you get the rel6 base image, your container, when it gets deployed by Docker, basically squishes the two together and then launches the container. When you patch it, you can either patch the base, or you can just come back with another layer that basically inserts itself and says, okay, here's the patches for OpenSSL or Heartbleed, right? So you come into this layered approach, and that, again, extends the flexibility that if you want to, I need to back out that chain, you can either remove that layer or remove the base OS and stick the old one back in. So this whole concept of upgrading, testing, and then regressing those changes is a flip of a switch, as opposed to I just installed a bunch of bugs and whoops, let me go to my tapes and start to reinstall the LS and recover things.
Yeah, no. But if you have some common library that dependent on our library that share in multiple containers, now you have to deploy upgrades, version, and everything.
I think
Before you just updated the OS, SSL and you're done, right?
So I think what Christoph was driving towards was that the host has this knowledge that when I have a Docker image, it has this layer on it that conforms to this OS. And when you have these different containers, the container format says, I'm a container, but I'm formed of all these different layers. One layer is the rel6, one layer might be, the Apache binary, one layer might be like the HTTP stuff that goes in that. So when you talk about patching like the rel6 layer, if you patch that once in terms of that layer, and you effectively retake the container, you stop the process and restart it, you get this whole new user space, and you're good to go.
And you execute that without rebooting the host, right?
Right.
So there's a lot of pain that's removed. Another thing, when we talk about atomic shortly, in that model, you can upgrade the host while it's running, essentially put in a new base reboot the machine and upgrade the host. So you can basically upgrade the host while it's running, doing things, and then reboot and get the upgrade.
So now, so the certified containers, are those something that Red Hat is charging money for, or is that something that is just available for remote?
That's another good question. I think, so I understand this is going to be recorded on YouTube, so be careful. Yeah, right. So I think, that's something where we're working with our ISP partners to figure out what the best model for that delivery mechanism is. As it stands, I know that, companies like ISP partners that Red Hat's been working with for a long time, they are investing in containers. I don't think anyone's thought about the business process beyond that.
Okay, but let's just take something like Mongo, which is clearly open source and GPL.
Sure, yeah.
Is Red Hat offering a certified container for that, for instance? Could they even charge for something like that?
Yeah, I mean, to answer your question, as of right now, we are not charging for it. But what we are thinking about is providing, using our subscription management system to help the ISP provide a mechanism for which they would understand how
Even in the canoe model, you can't charge for, you have to talk to it, you can't charge for distribution of it, you can charge for like options for it. So that would be completely
Yeah, the GPL only stipulates that when I ship you a binary, I have to ship you source code along with that. That is the stipulation of the GPL. I mean, you could charge for that container. You could charge to get that binary, but you have to ship source code along with that. You can compile your own, which is where you end up in the untrusted container model, where you're not sure like where you're getting it from, who's compiling it, what other stuff they could be putting into it. That's really where they're following.
But then it also sort of allows the where you can sort of standardize more in the host OS to as long as it's possible container. You can let people build environments in there and sort of simplify the host OS distribution.
Yeah, absolutely. So that's why we developed Raw Atomic, which we're going to talk about in a minute. Atomic is basically just enough operating system to run all the container framework that you need in the system.
If you're familiar with like the ESXi, just enough ESX that basically provides a platform that plugs into a center. In the KVM world of Red Hat virtualization, it's called Red 8, which is just enough Red Hat to be a KVM hypervisor. Also small footprint deployables, that kind of thing. Atomic is what you said, just enough Red Hat Enterprise Linux to a Docker.
So was there a question about that?
It's pre-configured to do all the Kubernetes stuff. Yes.
Is there any sort of management system in place to facilitate restarting the container using what if you were to update SSL? You might want to keep the system backup on the substation so as long as possible until the moment of the restart. You don't want to drop a huge package from the system. Whereas if you could have the container running on open source, have SOCAD or something floating all the corporations that can see the container, and then you can have like SOCAD which container is floating close to resolution. Is there anything like that open right now?
So I think how most customers are trying to solve that problem is having effectively, it's a distributed computing problem. So effectively putting a load balancer in front of it, letting the load balancer make those decisions of, oh, well, I can reach this host, I'm going to forward it there. I can't reach it, I'm going to forward it here instead. And then when everything does come available, that's when it figures it out. That's why like things like OpenShift, which Christoph mentioned at the very beginning, it has that built-in load balancer to figure that out for you. So it's doing all that decision making for you. Otherwise, if you're just running a simple app with one instance of Apache, one instance of MySQL, I mean, it's one instance of whatever, write your custom code. I think that's most applications that are out there. It's just like restarting HTTP. Right? If you were to do that, you're shutting down the container, you're booting it back up. It's literally just like restarting the software.
I have a question too. Are these going to be available on CentOS 7 as well? Or just on,
There is an Atomic variant of CentOS 7. Yep. There is an Atomic variant of Fedora, although I think most of the work that's being done for Atomic has shifted to Atomic. But yeah, so for, again, mentioning Project Kala, my demo for Project Kala was all done on Fedora.
You get would you be able to get updates to package storage and stuff, or would you read it?
So there's a different mechanism for patching Atomic that we're going to talk about in just a minute, but it does change. It changes the way you manage the host. That's probably a good way to put it. You're no longer applying RPMs individually. You're applying entire system updates. and that's what they call the atomic update. So I'll let you know. That's a good question.
Okay, so let's see what we've covered here. Isolation of Linux containers. We talked about the format with Docker, orchestration with Kubernetes. Touched on atomic and this concept of RPM OS tree. And you're going to correct me if I get this wrong. But basically, when we talk about this orthogonal set of technologies between RPM and this imaging methodology with Docker containers, the way we build the Docker container is still leveraging the traditional tools of RPM. And then in conjunction with thing called RPM OS tree, that's what gets you from I've got my environment with my runtime and my application to here's my deployable container. Right?
So I mean, with it's definitely changing the way you think about host management, because most people, when they hook manage host, you're thinking about applying RPMs directly. Like I have this RPM that solves this security problem, and I'm going to patch that RPM directly. Within the OS tree model, you have to think about it like you're applying a system update where all these changes are going to occur at once, and then you basically restart the machine, or sometimes not, doesn't always require a restart. Like let's say if you had a change that required a kernel update, you'd apply this entire OS image, you would restart the machine, and there you go. That's your newly updated thing.
Here's the software development. So we talk about continuous integration, continuous development, common terminology we prior to that. And you talk about like agile development versus waterfall style. I think what I've always heard is that one of the primary reasons why lots of software projects fail is because you set up all your design goals in the beginning, and you build code for 6 months, and then you realize you're broken, and you spent your budget, and then the project's done, right? In the agile model, you want developers to come up with really cool ideas, launch a container, do the development, test it, and basically validate in an hour that it's either a good idea or a bad idea, and they basically start coding in very small chunks and testing basically in real time. So this whole methodology fits right in with what agile development trying to accomplish there. So more than a container, right? So like as I said, you can get Docker installed and launch a container and start to fiddle with it. But when you talk about enterprise scale and deployment and management of containers, you really need a lot more to think about. You need to get to the big picture here. So, Red Hat as a company, we're working with partners and trying to certify ISV apps, build marketplace, have these registries so you can get trusted images, and then also have the Kubernetes tooling. Talk about OpenShift. So OpenShift is our PaaS platform that's been around for a couple of years now, and we initially deployed it as a hosted solution. So there was nothing on-premise that you could do with OpenShift initially. It was something that we ran at Amazon that allowed Red Hat customers to start fiddling with development. And when you signed up for this, you basically got a small container running on RHEL 6 at the time. There are pieces of the container plumbing, the capabilities in terms which existed in RHEL 6, which was basically enough to make OpenShift a viable solution. And the way it worked is customer would sign up, swipe the card, say I need an OpenShift image, and then when they started their development, it looked and smelled and felt like their own dedicated operating system. But because of containerization, they're actually sharing an Amazon AMI with 100 or 1,000 other users. So again, it's a complementary technology to traditional virtualization. So this big marketplace. I'm going to try and start writing it. You actually want to get some demos. I think that's where most of it's going to make more sense. This is atomic host, minimize footprints, classify maintenance, and orchestration scale. Basically, configured so that everything works with Kubernetes and basically meant for large scale heat management. So what does that mean? Linux kernel, SE Linux turned on, still uses systemd, tuned, all these things are part of RHEL 7, cooked in there. Technology like Kubernetes, but the learn the right model correctly, deploy all the software into the call channel. So a lot of the pieces from the application channel well, that's all included in the you don't need the atomic, you still use standard all settings and set the channel just doing all three pieces. Yes, I mean, the containers are full containers. You have, RHEL or CentOS installed on your laptop. I don't think you need to reinstall Atomic on it. But if you have KVM enabled, you can basically pull down, the Atomic host, install it into KVM, and start playing with it.
That's what I think for definitely for things like Vagrant, that model.
Everybody familiar with Vagrant?
No. So Vagrant is a mechanism that several people created that effectively make it really easy to spin up these sandbox environments for testing applications. So Vagrant on Mac, for example, will use things like VirtualBox to then create a sandbox environment where you're going to test. You can use an atomic image. That way, if you want to deploy what they call a Vagrant image, that's basically a host that we talked about, host OS. Deploy a RHEL 7 or CentOS you're using Community, deploy that as a Vagrant image, and then deploy your apps on top of that. So that's one way to utilize Vagrant. Vagrant is API for VirtualBox.
I would love to do, think of it at a higher level. You create an image that's Vagrant, and then you take it to your Mac. On Mac, you use whatever the virtualization platform is, will run the Vagrant. There, where your links have KVM. You have to remember the next place. So you basically take a little more portability across the platform.
Yeah, too. I think that it's like one command line to do that.
Back at that previous question before that, I'm assuming you pick up a new server hardware these days. There's nothing on it all yet. When you first build Atomic, or you have a chip, which would then install Atomic automatically.
So the OpenShift is going to, generally speaking, OpenShift is going to abstract you from the whole container experience. So you interface with Kubernetes or Docker directly. You're going to interface with your API. It's designed that way because we're going through OpenShift 2, which is based on this form of containerization that's mostly using Docker in version 3. But the API that is developed for OpenShift is exactly the same. So the experience that they have between the underlying tech setting between version 2 and version 3 is identical. So they have created no problem. Now, as far as how people start leveraging containers and playing with them, I mean, the way I started with it was just using Docker directly on the laptop. Makes it really easy. There's a ton of documentation out there. Just do a Docker run, and you just test it out, see how it works. The next step is install your virtual machine and do the same thing because it just makes it easy to have a playground. The third step would be laying Kubernetes on top of that. So seeing how Kubernetes is interacting with Docker, that would be the third step. And then the fourth step would be setting up multiple Kubernetes instances, and tying flannel, having them tied the networking together, and then interfacing with that. It's a very advanced topic, something that sort of gets covered in the demo, but I think we might as well start with the demo.
So this is the first one. And what you're logging into here is the OpenStack dashboard. So we don't have audio up front, so you can narrate for you what's going on.
So, I keep talking about Project Paula. If you want a great way to demonstrate, I think that maybe one is a sort of Google Maps. Okay. Okay, so when we talk about RHEL Atomic, So what all right, so what we're going to talk about is spinning up atomic. So all this other stuff, just like what we use internally when we talk about like giving environments to particular users. This is an OpenStack environment that I maintain for the entire architect team. So if you wanted to spin up architect, we had, or atomic rather, you log into our architect labs, to run OpenStack. It allows a very cheap way to spin up a VM. And he's going to pump in a bunch of stuff that Atomic used to require. In particular, he's going to set a password that Atomic needed. That way he can SSH into it, because by default, it's only going to enable your key. Okay, so he's on our system. He SSH'd into it, and he's going to show that, okay, Kubernetes is installed. It has this like kind of old and wonky version 0.3.
So this host that's running is Atomic host.
He is SSH'd into a host running Atomic. You can see the host name is cloud user at Atomic Test. So he's SSH'd in. He uses this command called OSTree. Now OSTree is, so he used RPM to query the system vault that's installed, but he's not going to do a yum install or a yum update. He's going to tell it to subscribe to the beta BLU tree that's hosted internally overhead. When he does that, it's going to use OSTree to then grab all the stuff that it has to understand what's on the image, if it needs updating. In this particular case, Kubernetes was updated from 0.3 to 0.4. Doesn't sound like that big of a change. Actually, for Kubernetes, it was a huge change. There were several things that were broken in the version of Kubernetes. So we're going to, just for the sake of time, we're going to fast forward this. Oh, okay. All right. So in this particular case, he's going to tell Atomic to rebase to the beta channel. You see that it's going to delete the previous reference. These are all the packages that were changed. They removed all these old tools and tools, Linux. Then what he does is he does.
When you say if you're going to rebase.
So it's rebasing to the newer OSTree image. So he told it, hey, I want to subscribe to the beta channel or whatever the OSTree image is. So it goes out, it finds out what's the difference between this and this image, prints it out, says, here you go, this is what's different. What it's doing here is that it's going to, so he does a sudo atomic upgrade here. What happens when he runs upgrade is that it's going to authentication as part of the rebooting system. He's going to authenticate it to root. He's going to tell it to reboot in this particular case because there are all these systems things that change. He's going to SSH back into it. So right now he's waiting for the reboot. When he does that, this is a quick preview. You can already probably guess what happens. He's going to run RPM SQI against Kubernetes. He's going to see that Kubernetes is updated. What's it? So it updates to 0.4. Now, it's just a different way. Like, it's not really that hard to grok. He didn't do a yum update for Kubernetes. He did an RPM OSTree and upgraded all these other things along with that. Kubernetes was not happy about that. A different way to think about host management. So the reason that Red Hat has invested in this is because doing that type of host management at scale for the billions of containers, solving that type of problem, this makes it really easy to manage that type of problem. This is where we talk about Hala.
Can you lock?
You guys good so far?
Technology at scale.
Okay, so I think this is probably not going to be as interesting, but I think what we'll probably hit just for a moment is some of the functional stuff that happens when you go to build a Docker container. So, excuse me. what James is working on is that project follower. It's really the first, type of application that we delivered for anything that was containerized. So what James has done is he edited his build conf to give it a private registry where it's going to upload his container. What he's doing now is he issued a build command, which is this script basically like has all the build commands in it, has the Docker build file that's separately that we can probably review the Git repository. But what it's doing now is it's using that Docker build command to say, I want to use my Fedora RDO base. That's going to be my first layer of the container. What it's doing now is once it gets that container, that Fedora RDO base, it's going to run this command, run my install my server. So I mentioned earlier, like what's the difference between a container and RPM? Using RPM makes this really easy. Right? Not using RPM would make this really painful. You run into all those old problems that we used to. Yep, that's right. Nobody wants to do that. So this is effectively what what it's doing. It's setting up some different things. I want to pause it here so I can talk through it. You'll see that it creates what's called a Docker volume. It's going to create this directory var log mydb. The expose command, expose 3306. Yeah, sure. Okay, so
doesn't work for me because I'm colorblind, so I can point the laser at the screen.
So this expose command here, expose 3306, when you specify that in the Docker file, what it tells the container to do is, I have this application running on 3306. If you're going to orchestrate me,
Whoa.
Thank you.
That's a saber. That one I can see.
We can fight each other with this.
We're in red one, I've got a red one.
So this entry point, this is a script that that was created, and so what happens when this thing actually runs is that when you build a Docker container, it's going to execute the entry point, and then it's going to execute the command. The entry point is effectively what sets up, in this case, MariaDB Galera. So it's going to run all the stuff that's in this entry point. I can add it for you. It's basically all these like setup commands from MariaDB, and then it executes MySQL DB. I can go into some of the idiosyncrasies about the entry point and the command. It's not worth it. What it does, because he specified in his build file that he wants uploaded to a private registry, it uploaded to here, a private registry, right? And it created this Fedora RDO MariaDB, which is the name specified in the Docker file. It uploads it with a version of latest. Another thing that we kind of glossed over, and that's really impressive about Docker, is that it versions the containers when it pushes them out. So if you have one version, you push it up to the registry. If you get a new version, you push that up to the registry. It knows that there are different versions. So if you have a problem with the new version, it's very easy to effectively back out into the old version and just start running it. So it's a lot easier than downgrading RPMs. Downgrading RPMs is really a painful process that people have been trying to solve for a long time. This makes it really easy to effectively stop the process running old version. So here he's pushing it out to the private registry.
Actually, don't pause.
Yeah, sure.
Anybody here run into the problem where you want to undo an install? Just with the LVM, if you're using logical volume management, you can do something called a snapshot and then merge an old snapshot back and basically regress in the file system. There's ways to do it. That's for another day.
So there's only 30 more seconds of this. So this gives you an example of what it's like to build a Docker container. So I didn't really show a strong example of what does that Docker build file look like. If you'd like as a follow-up, you can talk about I can just send you guys all the call Git repo. You can look through that. It has all the things you need to orchestrate it through Kubernetes, as well as all the Docker build files you need to build these. Right? So effectively, after it's done building, you see that it's gone. It's gone. Okay. So this is that repository that he cloned at the beginning. That has all the Kubernetes and Docker build files in it that we use for this. really it as far as building a Docker container. That was the 3-minute overview. It's really not that painful, although it does take some, there are some tricks that you have to be aware of. The first is that the container is, you have to make it re-entrant. So when you stop it, it's going to run all that stuff at the beginning again. So you have to make it check to see like, oh, did I already run the setup stuff? If I did, okay, skip it. If I didn't, okay, run it. This is the first time I'm being run. So so problems like that are things that you need to be aware of. There are a couple other nuances to it, but generally speaking, one of the reasons why containers took off so quickly is because they're pretty easy to handle. Okay, so we're going to go back to this internal OpenStack cluster. James has set up a few other hosts. This atomic test host is what he has set up. Okay, so we're going to go back into. So I'm going to pause here for a second. So we're going to go back into, like I mentioned earlier.
Mind if I point something out?
Yeah.
Correct me if I'm wrong. But the reason we're using OpenStack here is basically it's a mechanism to launch an atomic host. So it's the same if you're using VMware and you put atomic host into a VM and then just using vCenter to kick it off. We're just happen to be using OpenStack. So there's no dependency that we're showing here that basically we're saying OpenStack and Docker.
Yeah,
we're just using it as a virtualization platform.
Yeah, you do not require the two. OpenStack is just a really cheap and easy way for you to get a virtual machine internally. So I'm just pointing out a couple of things here. So I mentioned earlier that we have this K8S directory within the column. Kubernetes organizes itself around the terminology pod, replication, and service. So I mentioned earlier you could have this pod. In this case, if you look at the MariaDB pod, you'll see that I have this. I'm going to specify my password as the environment variable BLU password. I'm going to use this image. This is the image that's hosted that I'm actually going to start when Kubernetes tells the host, hey, start this container. I'm going to use this custom port 3306. I'm going to bind mount all of my SQL. And this is going to provide my IDB.
Everybody understand bind mount? It's bringing its own version of varlib MySQL. So when Docker launches it, the container is going to have its own piece, and then you'll have the rel base basically just going to overflow that.
Okay, so I'll pause it here again. So I mentioned earlier that you have the Kubernetes has the terminology of pod and service. You have a pod that can be multiple containers deployed as an application. But to be externally reachable, you need to define an accompanying service. What that does is it tells this other technology called the Kuber proxy. Basically tells it, I want you to expose this port, and I want you to route it to this application. That's what the service definition does. So that's why the service definition is pretty short. You have this definition of MariaDB. Here's my service, port 3306. That's it. It's not really that complicated. So here James is pointing out, hey, I have my container port. I've got my external port. So you could theoretically do like a port remapping of like my container port's 3306, but I want it to listen externally on like port 8000. Okay, if you look at the Docker images, he already has a few that are already provisioned on his machine. Docker images is just an API thing for Docker. So you can see what the machine actually has hosted on it right now. If you do this ps-a, this tells you everything that's running that Docker is doing. So like there's no container running at this point. But what James is going to do is he's going to tell, he's just going to watch Docker to see, okay, well, I'm not doing anything right now. Once I execute this command, you'll see things start to run. So this command kubeconfig, this is how you interact with Kubernetes API. So he's going to tell kubeconfig, hey, I want you to spin up this service. I want you to create this service. Then he's going to say kubeconfig, it's going to list services. So he has defined this service MariaDB on port 3306. Next, he's going to create a pod, which is the application that's actually going to start running on the host. Okay, so what he did here was he told Kubernetes, he said, create this pod and use this file MariaDB to pod. Right? So now if you list pods, you can see that Kubernetes is actually doing something. Here's the host it's doing it on. Now when you actually ask Docker, what is it doing, you can see that Kubernetes spins up this latest container, which is how it helps monitor what that container is doing. But it also spins up the container that we told it to, spins up that MariaDB container. So you can see what the container is doing. So Kubernetes said, hey, spin up this Fedora RDO MariaDB container, use the latest version, and you can see actually what the container is doing, running that entry point. That entry point came from when I built the container. It said, whenever you get run the entry point.sh script first, and then run MySQL save afterwards.
Why do we not call it autoexec.cat?
Pretty close. Pretty close. So I mentioned earlier that you could theoretically run like a supervisor D as part of your container. People try and shy away from that model because if you were to monitor the container for an application failure, you will see that supervisor D is probably running, but then the app you really care about is not running anymore. So cAdvisor is the utility that used to do that. It's just going to check, is the thing as specified in my entry point RTN still running? That's all. So what James is doing now is he's saying, okay, well now that I have this container that's running on the system, I'm going to give it this disgusting command line. Yeah, this is a pretty gross command line. But what he did here, which is not obvious, is that he entered the container. This is sort of like if you can imagine running the Unix jail, hopping into that jail, all of a sudden you're in the container, you're looking at the processing space, and you're actually looking at the file system that MariaDB can look at. So I can see, after I enter the container and I run this PSEF, I can see that I'm running MariaDB here. And that was started by that entry point. So what he's doing now is he's going to show, I can actually, from another host, I can communicate to this IP and it's listening on 3306. So this is an externally available port that was started by Kubernetes orchestrating container deployment with the service definition. That's all it is. So you can interact with it. Basically, it's just it's a cheap demo for showing, hey, look, I deployed this MariaDB instance. I can interact with it externally. So here's the host that he logged into. Here's the container he spun up. Here's the ID account defined. The scoop config list pod, so basically tell me all the apps that you have running. Where he says list services, tell me all the service port definitions that you have available. So you can see when we developed Kala, there are all these service definitions we had to create because you have all these different ports that you have to enable to interact with OpenStack. OpenStack is a pretty complicated one. So, Glance API is going to listen on a port, registry is going to listen on a different port, Keystone, admin, and public listed on different ports. There's just a lot of different ports that are involved. So in this particular, he's saying, I'm going to create I'm going to run this scoop config command that's going to create the service definition for Keystone. Keystone is going to listen on port 5000. I bet you can guess what's going to happen next is that he's going to create a pod that's actually going to deploy the Keystone container. And that's going to listen to it. It's going to create that service.
I probably flew over the slide in the beginning, but K8S, case, is a short acronym for Kubernetes. It's basically K, 8 letters, followed by an S.
So he's back in the container. He left the container. Okay, so you can see that MariaDB is still running. It created this pause instance for the stuff that has to go on with etcd. Any second now, it's going to start the going to start the other container, which is what you specified, that keystone container. Okay, so there's keystone right there. It's running start that SH at the entry point. So he created the service. Service said, hey, I've got this port that's open. He created this pod. The pod actually said, here's the container you have to run that connects to the service. So now what's interesting is that as soon as he started up that keystone pod, the keystone startup script was the first one that said, hey, I don't have anything that's in MySQL or MyDB in this case. I don't have any database entry there. I need you to create one. So what it did was it logged into MyDB and it created a SQL schema for G. So this is hopefully that helps demonstrate how the interaction model works between the two. You can have a service that spins up and interacts with MySQL. So now what James is doing is, if you're familiar with OpenStack, which what he's doing is that he's saying, okay, well I have my keystone admin port is 35357. I have this username admin. The password is Paula. That's by default was created when I started up that keystone container. And he's sourcing that because what he's going to do is he's going to fire the keystone client to then look at the user list to see what was created right now. So when the keystone container was created, not only did it create its own entries in MyDB, but it also created this admin user, and it created its own service entry, service catalog. So you can have containers do all sorts of things when they start up. It really is based on that start script.
Any questions so far?
Any questions? Well, intuitively obvious.
I find it hard to come up with questions until I actually get my hands on it and try it out.
Yeah, I mean, this is meant to show like it's not impossible to interact with, but there is an interaction model between spinning up a container, having them interact between each other, and how does Kubernetes spin these things up? How do they make them publicly available? So in this, he's going to look at let's see. So how does Kubernetes actually start? If you want to do like a full OpenStack install using Apollo with containers, how does it actually work? So what they had to do is because there's so many pods and so many services that are defined, they created startup scripts for stuff. So they're looking at here's all the images that we need to use. Like I mentioned, OpenStack is a very complicated animal. There's about a dozen that you need. When you do this, when you tell the startup script, it's going to tell Kubernetes, spin up this pod, this pod, this pod, this pod, this pod, create the service, the service, the service, the service. And so what James is going to run through is he's going to run through the actual deployment of, okay, well, I have all these pods I need to deploy. Right? So if you ask Kubernetes to list pods, it's going to give you a list of here's all the apps I need to deploy. And this is everything it takes to run OpenStack. When he goes to list services, you'll see here's all the ports and here's what they're associated with. So I have 9292 associated with API. If I go back to what Kubernetes is actually doing, Kubernetes told the Docker API, I want you to run all these containers. Here's a bunch of command line options I want you to run with them. And so now you can see how Kubernetes is orchestrating all the deployment of all these containers. All these containers are interacting with each other. Typically, you have the ones for like, you have Keystone and MyDB that need to get spun up first. Those are really the bedrock pieces of technology within OpenStack. And then everything gets spun up on top of that will communicate to those two services to then spin up their own service. So in this case, James is going to log in. He's going to show the same, excuse me, the same OpenRC file, which is what we use for these environment variables. This is how we're going to interact with OpenStack. Okay, so when he does that, you can see as these containers have started spinning up, you see that, glance in this instance, it got a container that was spun up, and it interacted with MariaDB and Keystone to say, hey, I need to use those queries. I need all this MySQL. And so you can interact with these.
Right.
I got a question on that. You're saying that MariaDB is one of the basic components.
Right.
Is there any way you can use Postgres instead of MariaDB for that?
OpenStack, no. But for a custom developed app, absolutely. I mean, OpenStack is just an example of an application. It's a complex app, so it makes for a good example of like these interaction models between the containers, how the service definitions get created, how you can see that one container can spin up, depend on another one, and then make changes to that other one. So MariaDB is a dependency for all these other things that you get spun up. So like Keystone is going to say, hey, I need MariaDB. Nova is going to say, hey, I need Keystone, which then depends on MariaDB. So you can sort of start layering applications on top of each other. So if you can imagine like your typical app that gets deployed, my typical app is Tomcat plus MySQL or Postgres. I need Postgres to be there as a foundational component. I'm going to spin up my app, and my app is going to set up all this stuff that needs Postgres. Okay, so we talked a little about how there are sometimes these the stuff that's going on now. Looking at the Docker images that are there, you see this virtual size. Okay, excuse me. So all these sizes, these are kind of a gross inflation of the container image based on a lot of development work that was done. These images, I don't think are necessarily reflective of the typical Docker container size. Typical Docker container is going to be anywhere between 2 and let's say 500 meg, depending on how much communication is. That's really what makes it so portable. Is that the big pain with virtual machines is that you have to ship an entire machine every time you need an application deployed. So that's why deploying one app per virtual machine became a very cumbersome model. With Docker, if you can imagine these guys being a couple hundred meg, it makes it a much different ballgame. So you can do a Docker pull down a couple hundred meg, all of a sudden you have your app and all the associated logistics. Much different conversation as far as how portable applications are. I guess I'll let James. Okay, so what he's going to do here at this point, the demo is really coming to a close. You see all these different things interacting with each other. It's kind of a text line demo. But it works.
Wave your hands a lot.
Yeah. So you can see you have if you look at all the stuff that's ever been run, you see a lot of stuff. You see these statuses, from like instances that you shut down previously. You can see what's currently running. This is just him interacting with Docker, showing what's running and what's not. Okay, so this is again showing that example. When I demoed this at OpenStack Summit, there was a cheers throughout the room because no one could believe that, oh my God, you actually use a container to deploy a service and create a user organic keystone. I'm going to fast forward a little bit. I think you guys kind of get the point.
Have any of you done an OpenStack install before?
Okay, so
it's a very non-trivial thing. You can find a tool out there called PackStack, which will help you as I want to play with OpenStack. PackStack will basically deploy OpenStack on a single host, so you can play with everything within a single host. But when you want to deploy it in production, it's very complicated. It's networking and architecture, all this topology together. So that complexity by leveraging containers, now you can use these container installation tools to basically set up OpenStack. That's why it finally cracked the.
Yeah, the difference is you take a very complicated application. I think you guys probably get it from the demo how complicated OpenStack can be. You take a very complicated microservices application, you give it a bunch of hosts, and instead of you having to manually run this installer and go through all the chef stuff that you're probably doing internally at this point, instead of having to wrangle all that, you just hit the start command. You tell Kubernetes create this pod, just the language, the DSL, and it's going to execute and start executing all these applications for you. It makes it really easy to then deploy applications. It makes it really easy to redeploy applications or move applications. So the common problem I get from customers is that, do I have, instead of getting two apps on the same box, or just one VM that's running my contact server and my SQL and my custom code, and I want to separate all those out? That's an extremely painful thing to do. If they're all sitting on one machine, they all have the expectation of sitting on one machine, and they're all in the same process. So that's what happens when apps grow up and they get a lot of use. You want to start separating out services. That's usually the first problem to solve. So containers make that a trivial problem to solve, because then it's very easy to take like their custom code component and move it to another host. So you have that flexibility. So that's really it as far as Kubernetes goes. It's not perhaps, like I said, the greatest demo of all time, because it's very text-line driven, but what it's meant to demonstrate is that there is a mechanism for orchestrating containers. That containers do solve a very real problem, and that containers are able to. You can take a container from a developer workstation, take that, and then roll it into production, and then let it go. That's it.
Questions? Comments? Feedback? Confusion? Go for it.
Yeah, so I had a question about sort of non-Red Hat-based environments for Docker. So like this Debian world, and then more broadly, like EBSD or pretty nice what's the situation with that?
So with the other operating systems, I mean, like WGFC has Docker support into it. Ubuntu has Docker support into it. Even things like Microsoft Windows, Azure is now a platform where you can run Docker container. Not necessarily that it's technically leveraging the same kernel, although what they did was they basically hacked on this interface to make it look like a web client. So what you like in PC or stuff. So it's kind of a hack on top of their kernel.
Wait, you can run a Linux Docker image on Azure?
Yeah, but say, I mean, with say.
I don't know why you'd want to do that, but you could do it.
I mean, feature-wise, if you want to run Docker on the Red Hat family or Docker,
Between highly unstable and insecure.
Yeah.
No, it's not.
No, I mean, aside from what I'm sure you guys consider fundamental problems.
I think, yeah, API commands are similar.
Are there major features that are not supported on the Debian universe that are supported?
Yeah, I think when it comes down to support, if you're talking about like, can I run the same API command here versus here, you're going to find a very similar experience between Fedora, Debian, and even RHEL. I mean, these projects are moving very quickly, so you'll see like Kubernetes 0.4 is in Debian. So you'll get a very similar experience if you use the community stuff. It's when we start talking about like all those other enterprise type problems.
Yeah, unfortunately, if I'm hacking around, and
Yeah.
I just decided, because I looked at running it on my laptop,
Sure.
I just want to spin up something to play with it, there shouldn't be a major difference.
Oh, absolutely not.
I think some of the fundamental differences might be like SE Linux enablement.
Mm-hmm.
I don't know what the other distros are doing with that. I know also early on in the Docker world, they were using Union FS, which is now shifted over to using Thin OVMs or something, right? It's using Thin Pool. So that was kind of a Red Hat influence, because Union FS, I guess, was viewed as something else before war. I'm not sure what the reason was, but Thin Pool was something that really kind of pushed Docker to the next level of being able to build containers that could layer easily in a supportable way.
Yeah, Union does have some technological challenges. So the other thing about SE Linux is, we talk about running it across. SE Linux gives a layer of isolation to a container, so basically means that by this app, even though it's rooted, if it were to somehow get out of that, or to use a plugin another, if there's some sort of kernel bug, you're still isolating that process to as far as I know, the Debian user space is only shipping, say, about 2% of their entire user space that has SE1 on it. But they have 15,000 packages. At the same time, it's a very small percentage of the distribution that has Ubuntu sort of inherits that, where you're kind of taking different approach to that.
Anybody not know what SE Linux is? Solve that problem. That's the reason we have to use it.
There you go. Okay.
And things like, I mean, is there support on BSD or something where there's HTTP or AIS and that not really? This is more of a curiosity.
Yeah. So FreeBSD is, they do their own thing. Like they don't have KVM support. They've got QVAC. So they kind of do their own thing. I think that containers are compelling enough that they'll probably port it to their kernel, which is not there yet. Things like AIX, they do not have container support. I would be chopped, capital S. If container support ever made it into AIX, I think, wow, yeah, that would be something. But what you can do is you can run, you could theoretically run a Linux on top of Power. So you could theoretically do the same thing as anything. I don't think it's supposed to be on top of Power.
So basically, the whole argument is all pretty much like you can stack a bunch of layers and they should not be doing it all the time.
Yeah, right.
And that's the whole advantage of containers, is that you don't have that emulation penalty that you do with traditional work.
Yeah, exactly. With traditional work like KVM or Power VM, you're going to have that hypercall layer. And that really is when you spin up a VM. All the emulation stuff that Christoph talked about gets communicating through that hypercall layer. So it gets, in the Intel world, it gets processed through like a different layer, which helps speed it up, but it's not the same as running on the same file. And so when you talk about like booting a VM, yeah, that could be like a couple minutes, versus a container where it could be a couple seconds. That call demo is impressive to people who have tried to deploy OpenStack, because not only are you deploying OpenStack using a start command, but you're deploying OpenStack quite literally within 45 seconds. That's an impressive problem to solve.
In the OpenStack world, that's insane.
Yeah, it's crazy. Most of the time, just to orchestrate that deployment, you're talking about like probably like a challenge that's going to take over an hour or so. Containers rapidly reduce the time.
Every time you launch a traditional VM, you forfeit a gig of memory for the kernel, all the other CPU resources that run the operating system. In container, it's just the app that you're forfeiting resources for, so you get performance and opportunity for much greater density, which is going to boost utilization, save you money, make things better. Pardon me?
It's memory footprint.
Right.
So yeah, I mean, just to give more, give a better reference to what you could take. So I think Christoph mentioned earlier that we run OpenShift online on Amazon. It's great that Red Hat can offer that service, right? It's a great utility for people to go and they want to just try the developer experience. They want to try like, hey, I want to run this version of MySQL and just push code out and see if it works or not. It's great for solving that problem. The reason we're able to do that and offer it is something that's economical to Red Hat is because we're not spinning up a VM every time a person spins up a V. We spin up a container. Spinning up a container means that you can collapse quite literally 8,000 containers onto a single node. And so we can run an extra large node and spin up thousands of containers on top of it. And that's what makes it economical. So I think for dev environments, that's why nobody wants to pay for dev. I've been doing my job for almost 8 years. I can tell you definitively no one wants to pay for that. No one wants to pay for the hardware. Nobody wants to pay for the software. It's just they expect it, but they don't want to pay for it. And I understand. And so what containers offers is the ability to create these hyper-dense environments simply for development, where you don't necessarily need the same performance requirements and guarantees that SLAs that you provide. But it means that I can spin up my app and I can see it used like Tomcat and SQL. And when I'm done with it, I just terminate it, help it go away. That's one of the beauties of containers. It makes it very easy to do that. All right, I think that's it. That's all we got.
Christoph,
Thank you, guys.
We're out. Questions, comments?
I Yeah, I was wondering, could I get a copy of the slides and these 4 videos to post on the Blue website?
So all these 4 videos are actually posted on allthingsopen.com.
All right.
We can send a link to those. James actually wrote a very detailed blog post on, exactly what's going on and, the types of problems that we're trying to solve on a more mental level.
And I'll
Happy
forward
to
you a
provide
copy.
those links.
I'll send you a copy of the PDF.
Is it okay to copy those onto the Blue web server?
Yeah, sure. Any day they're offered under free.
Oh, yeah. I just have an issue with, like a lot of old files, sometimes people want to review something like 2 or 3 years ago, and the links has evaporated.
Oh, wait, I had a plug. Hang on.
What?
Never mind. Red Hat Summit's back in Boston this year.
Just let you know. We're going to